let's go ahead and do an example. Well, I mean, we've done a couple of examples, but let's just do sort of a free example. Okay, sucrose, which is table sugar, is GLC, alpha 1, beta 2, FRU. Okay, so sucrose is a disaccharide, and it is made up of a glucose unit and a fructose monomer. So glucose is a hexose, it's a 6-membered sugar. Fructose, remember, is a 5-membered ring sugar. The connection between the two, the glycoside bond that connects them, connects the anomeric carbon, which is alpha, and the number 2 carbon, which is beta configuration on the fructose. So let's go ahead and draw out the structure. That's our assignment. This is what we want to do. So in this particular case, we haven't given you a structure. What we've done is give you the name in shortened form, and we want you to draw the structure. Draw the structure. Very, very typical question on an exam. Okay. In this particular case, well, let me just go ahead and draw the, should I go ahead and, well, that's fine. So in this particular case, I'm joining the anomeric carbon of both. So again, I'm going to have to bring the carbons in close proximity. So I'm going to have to flip or spin the second monosaccharide. I'm going to choose the flip version. So let me go ahead and draw out my, so I choose to flip the second monosaccharide. Second monosac. Okay, and again, when you see an alpha or a beta on this second carbon here, this second sugar, that's what's going to tell you that you're probably going to have to do some spinning or flipping. If there was just a number here, like 4 or 5 or 3 or something like that, then you can just leave them alone and just connect the carbons. Okay, so let's go ahead and draw out our alpha glucose. So that's going to be like this. Alpha, which means the hydroxy is down here. And this is there, and this is there, and this is CH2OH. Okay, now flip the beta. Let me see, 2. I'm actually going to go through the process of putting this particular fructose together. So I'm going to start the process this way. So I'm going to do this in blue, just so you see, again, a little bit of a review on how it is that we actually create this particular ringed sugar. So fructose, again, is a 6-membered ring. So we have 1, 2, 3, 4, 5, 6. That's up. It's going to be down. Yes. Okay. So except this time, see, this is H2OH. So this is a ketone. This is a ketose. So the number 2 carbon actually has the carbonyl. So here, OH. So I'm drawing out the linear form. 1, 2, 3, 4, 5. Oops, I forgot. This is OH, and this is CH2OH. So this is the linear form. So I'm going to go ahead and take this linear form and draw it in such a way in order to create my ring. So let's see, I've got C carbonyl. This is CH2OH here. This is C. This is C. That's C. And then I have my OH. And I have my CH2OH here. So this is in free form that I've taken. I've rotated. I've brought the other thing around. Now, 1, 2, 3, 4, 5. That's right. So I'm going to end up attacking that right there. And what I'm going to end up creating is my beta fructose. So my fructose is going to look like this. And I have that. So beta, that means, so this is the number 1 carbon, right? Number 1 carbon, number 2 carbon. So CH2OH. Let me go ahead and number these. This is 1, this is 2, this is 3, this is 4, and this is 5. and I'll do number 6 in just a minute. Let me go ahead and put all of my substituents on here. Oops. As you can see, things get very, very, very involved. So let me go ahead and put my hydroxy there. Let me put my hydroxy there. Let me put my CH2OH over here, and I have my beta configuration. So this is my, write these out, this is my alpha glucose, and this is going to be my beta fructose. So I started with my fructose linear form. I created my regular beta fructose. This is the standard conventional arrangement. I'm going to be reacting this with this. Alpha 1, beta 2. So I'm actually going to be connecting this carbon with this carbon, which means that I'm going to have to flip this so that I can bring this carbon in close proximity to this carbon. Now, when I flip this, here's what it's going to look like. I'm going to do that in red. So the flipped fructose, I'm going to flip it. Well, the arrangement that way actually stays the same, but of course the substituents look different. So now what I have is, this is down, so it's going to be up. So this is going to be CH2OH. This is up, it's going to be down. This is CH2OH. This is down, this is up, so it's going to be down over here. And this is going to be up. This OH is up over here on the right. It's going to flip around this way, so it's going to end up being down here. So it almost looks the same, except the carbons are numbered differently now. So now we have our number 1 carbon, number 2, number 3, number 4, number 5, and number 6. So that, oops, go ahead and do that. So now I'm going to connect. This is our first sugar. This is our flipped fructose. I'm going to connect that carbon with this carbon, the number 2 carbon. And in case, so you notice this hydroxy is down, and over here, this hydroxy is down below the ring. So my final fructose structure, my final sucrose structure is going to look like this. I've got this. Let me make this kind of big. Okay, I've got 1, 2, there, there, there. Let me go ahead and draw my glycosidic bond. 1, 2, 3, 4, 5. This is an oxygen, and now I can put my substituents in. Hydroxy down, hydroxy up, hydroxy down, CH2OH. Now I've got a hydroxy down here. I've got a hydroxy up there. I've got a CH2OH here. And I've got a CH2OH. Actually, let me draw it to the left because there's plenty of room on the left. CH2OH. And there we go. Now I have my alpha 1 configuration, alpha 1 carbon on my glucose. This is my beta 2. You can write B2, 2 beta. It doesn't matter the order. That, as long as the alpha 1 is on the left of the arrow. And okay. So we have GLC, alpha 1, double arrow, beta 2, FRU. This is sucrose. This is table sugar. And you notice there is no anomeric carbon that's available. This is a non-reducing sugar. The 2 anomeric carbons are connected by an O-glycosidic bond. It's arranged this way. This is not the standard conventional arrangement. I've had to flip this fructose monomer in order to bring this carbon in close proximity with this carbon. This is the process that you go through. Again, glucose, glycosidic bond. Glucose is connected to fructose. The glycosidic bond is the alpha 1 number 1 carbon alpha configuration connected to the number 2 carbon beta configuration. That's it. We'll do more of these. Don't worry about that. We'll do plenty of these because it's very, very important that you be able to go back and forth, that you see a structure, be able to name it, that you be given a name, and be able to draw out a structure for it. Okay, thank you so much for joining us here at Educator.com.